You know, data is all around us, constantly telling a story. But what about data that unfolds over time? Every day, information's being generated second by second, month by month. Today, we're going to learn how to actually listen to that story.
So let's start with a really simple question. Think about your favorite clothing store. How do they nail it, getting just the right number of winter coats for the cold season? And how do they avoid being stuck with a mountain of them when summer rolls around? It's not a lucky guess, I can tell you that. The secret? They listen to the data's rhythm. Yep, they tune in to the hidden patterns in their past sales, and those patterns give them a pretty good idea of what's coming next. And that brings us to our first big idea, data that tells time. Because as soon as you arrange data points in chronological order, they stop being just a list of numbers. They become a story with a clock ticking inside.
The special tool we use to read this story is called time series analysis. Formally, it's the statistical study of data points collected at regular time intervals. But what does that really mean? Basically, it's the science of understanding the past so we can make a really educated guess about the future.
And this stuff is everywhere, not just in business. We're talking about daily stock prices, monthly sales figures, sure, but also a patient's heart rate monitored every single second, or even something as huge as annual population growth. The same basic principles apply to all of them.
So, how in the world do you find that rhythm in the data? Well, the key is to deconstruct it. You have to break the data down into its most basic, fundamental parts.
Now, if you just look at a raw time series plot, it can look, well, chaotic. It's just a squiggly line bouncing all over the place. It looks like random noise. But hiding inside all that chaos is a structure, and we're going to pull it apart. So it turns out pretty much every time series is made of three core pieces. The first, and maybe the most important, is the trend. This is the big picture, the long-term direction. Over months or years, is the data generally climbing up, trending down, or just staying flat? Okay, after you've got the main trend, the next piece is seasonality. Think about it. Ice cream sales explode every summer, right? Or how stores get crazy busy right before the holidays. These are the predictable, repeating cycles that happen over and over again.
And finally, once you've accounted for that long-term trend and you've factored in all the predictable seasonal cycles, whatever is left over, that's what we call the residual. It's just the random, unpredictable static, the noise in the signal.
And this is where the magic really happens. Look at this. You can take a messy, raw data series like that one at the top, and you can cleanly pull it apart into its three pieces. You see the clear upward trend, the predictable seasonal bumps, and then the leftover random noise. Suddenly, what looked like chaos is perfectly understandable.
Now, once we've broken the data down like this, we can start to do some really cool things. And you might be surprised to hear that one of the most valuable parts is the one we called noise, because sometimes that's where the secrets are hiding.
So what kind of secrets are we talking about? We're on the hunt for anomalies, outliers, the things that just don't fit the pattern at all.
So what exactly is an anomaly? The source material gives us this great, kind of formal definition. It's an observation that's so different from everything else that it makes you suspicious, like something else entirely must have caused it. It's the glitch in the matrix, the blip on the radar that just shouldn't be there.
And finding one is actually a pretty simple three-step process. First, you do the decomposition we just saw. Second, you ignore the trend and seasonality and you look only at that residual noise. And third, you just scan for any point that is way bigger or way smaller than all the others. Boom, that's almost certainly your anomaly.
Okay, so finding strange things in the past is really powerful. But the other main reason we do time series analysis is to do something even cooler, to use the patterns we've already found to predict what's going to happen next.
And that, my friends, is forecasting. The way it works is you take that trend and that seasonality you uncovered, and you just project them out into the future. You're basically extending the known rhythm of the data forward in time.
Now, there are a ton of ways to do this, but data scientists have a couple of favorites. There's exponential smoothing, which is a really clever method that pays more attention to recent data points. And then there are ARIMA models. These are kind of the heavy hitters, the ones you bring out when you need to capture really complex patterns.
And the end result looks something like this. You've got the solid line which shows what actually happened in the past. And then, you see that dotted line stretching out? That's the forecast. It's our best mathematical guess, charting a course for the future based on the patterns of the past.
Okay, so let's zoom all the way out. Why does any of this really matter? It matters because this kind of analysis is quietly running the world. making critical decisions in just about every field you can possibly imagine.
I mean, think about it. In finance, it's used to try and predict market trends. In business, it's for managing inventory, like our winter coats. But it's also used in manufacturing to keep an eye on quality, in demography to forecast population growth, in healthcare to analyze a patient's vital signs, and of course, every single day in meteorology to predict the weather.
So when you boil it all down, what's the one big takeaway? It's actually really simple but incredibly powerful. Time series analysis gives us a clear framework to understand the past, and by doing that, it gives us a much better map to navigate the future.
This ability to look ahead is an incredible power, and it leaves us with one final big question to think about. We are getting better and better at reading the patterns of the past. So the real question becomes, with that knowledge, what kind of future will we choose to predict, and what will we do about it?